Pre-calculus, reciprocal trigonometric ratios, part 1. So far, we've dealt with just 3 primary ratios, sine, cosine, and tangent. But there are another 3 ratios, cosecant, secant, and cotangent. They're the abbreviations CSC, SEC, COT. In the past, often cosecant has been abbreviated as COSEC, cosec, like that. But in fact, more and more, particularly in university texts, it's just CSC, so we'll go that way. Sine is defined as y over r, so cosecant, cosec is r over y. Cos, x over r, so sec, r over x. Tan, y over x, so cot, x over y. These reciprocal ratios behave in exactly the same way in the quadrants as the primary ratios, so all positive. In this quadrant, second quadrant, sine is positive, y over r is positive, which means that r over y is positive, so cosec is also positive. Tan in the third, and therefore cot, cos in the fourth, and therefore sec. Now, to have cosec, sec, and cot keys on a calculator would be superfluous, and we could end up with huge calculators. Anything that you can get to using a combination of keys do not appear on calculators, as the calculators would just be too large. So we have the 3 primary ratios on the calculator, sine, cos, and tan. And in order to get the reciprocal ratios, if we have cosec of 53 degrees, all we do is we invert sine of 53 degrees, and we get our answer. There are a couple of ways we can invert. We can use the fraction key. We can use the y to the x key with saying sine of 53 to the minus 1. Or we could say 1 divided by sine of 53 degrees. Use a calculator to find angles. If we're looking for an acute angle, sec theta 2,31. So all we do is we convert this to a cos ratio by inverting it. So if we say 1 divided by 2.31 or 2.31 to the negative 1, we get what cos of theta is equal to. Now we use our cos minus 1 button and we get the answer. With cot here, first thing we have to do is get rid of the 3, so we divide by the 3. Now the same thing, we're going to convert that to a tan value by inverting the 0.474. Use the tan minus 1 button, and that'll give us our angle. Let's have a look at our identities, extending them into reciprocal ratios. Tan cosec squared cos squared equals cot theta. Well, let's change everything to sine and cos. On the left, sine over cos. Cosec is the reciprocal of sine, therefore 1 over sine squared, and cos squared. And if you cancel down, you get cos over sine, which is cot. Cos of sine is cot because cot is the reciprocal of tan, and tan is sine over cos. We're going to take the left-hand side. It's always better to take the more complex side, or the side with which you can do some algebra for simplification. We can take the left-hand side and change to sine and cos. Sine over cos, cos over sine. Common denominator. Now you should recognize that from earlier days. Sine squared plus cos squared equals 1. And 1 over sine is cosec, 1 over cos is sec. And that is your right-hand side. In this one, we're going to take the right-hand side because that's the more complex. That's the one we can do algebra on. So we're going to change tan squared to sine squared over cos squared. Find a common denominator. Now sine squared plus cos squared is 1, so we end up with 1 over cos squared. And 1 over cos squared is sec squared. So there we are. Now that is actually a Pythagorean identity. Your sine squared plus cos squared equals 1 is a Pythagorean identity because it comes from x squared plus y squared being equal to r squared. So there we have our original Pythagorean identity. Now we have two reciprocal ratio Pythagorean identities. This one here, sec squared, is tan squared plus 1, and the equivalent cosec squared is cot squared plus 1. These are identities you need to know and to remember because they do not appear on formula sheets or in information booklets. And they're the spin-offs from these. You could use these without giving reasons, and they're the spin-offs from them. We can adjust them to a slightly different form and use those as well. Let's just have a look at some examples. These always look pretty complex, but if you're observant, you'll be able to cut down considerably. You could go to cos squared over sine squared and find a common denominator in this first one, but in fact, if you have a look here, cot squared plus 1, there it is there, we can write cosec squared p instead of cot squared plus 1. Square root of cosec squared is cosec, and there's our right-hand side. In this case, I'm going to go to the left-hand side because there's some algebra I can do there. I can multiply out and then change to sine and cos. So there we squared out the binomial. Square the first, multiply the two together and double, square the last. Now, if you're observant, you'll see there's a tan squared plus 1. Tan squared plus 1. And tan squared plus 1 is sec squared. And immediately we hit the right-hand side. If we look at this third one, we're going to take the left-hand side, we're going to change to sine and cos. Sec in reciprocal of cos, therefore 1 over cos squared, and cot is cos over sine, the reciprocal of sine over cos. Therefore cos squared over sine squared. Now that becomes 1 over sine squared minus 1. 1 over sine squared is cosec squared, and there's cosec squared. If we subtract 1, we get cot squared. And that's the right-hand side. Just a brief thing on co-ratios. Co, as in from complementary, adding up to 90 degrees. We already know that sine of 90 minus theta is cos theta, and cos of 90 minus theta is sine theta. Sine 10 is cos 80. Sine 50 is cos 40. Cos of 25 is sine of 65 when they add up to 90 degrees. Now, sec and cosec are also co-ratios. Well, quite simply, secant, add a co, you get cosecant. That's why they're named that way. And tangent and cotangent. Tan and cot are also co-ratios. We'll use those later. A summary of what we've covered. These are the ones you need to have in your memory when you go into an examination.